Really interesting question. If x is in the domain of the composite, does it have to be in the domain of the kind of the outer function, the f? So let me just draw a quick picture to try to wrap my head around this. So what are we doing? We're taking my x and we're doing, I can't really remember what the colors were, but we're doing g first to give gx, and then we're doing what? We're doing the f, aren't we, to give the composite. So f composed with gx. Remember, this is just by in previous notation or standard notation, f composed with gx. So does x need to be in the domain? Well, I think from this picture, no, because all that has to happen is you need x obviously to be in the domain of g. That has to make sense. But all you need next is gx to be in the domain of f. So I don't think there's any problems here. I think it's completely reasonable. But really, strictly, I need to come up with an example, I think. It would be good to come up with an example of something where it's in the domain of the composite, but it's not in the domain of the outer function. So what's just the simplest example? What bad stuff can happen? Something like square roots. So let's do an example. So I don't know, let's do f of x is equal to the square root of x, shall we? So that's got a bit of a restricted domain. You can't feed in negatives. And let's do g of x is equal to x squared. So what's the composite? F composed with g of x is equal to the square root of x squared. And if you think about it, that's equal to the absolute value of x. Okay? And that's got domain everything. So for example, consider x is equal to minus 1. So this guy, it's in the domain of the composite, f composed with g, x, which is the absolute value, of course, because you can take the absolute value, you can take the absolute value of any number at all, but minus 1 is not in the domain. Of f of x, which is the square root. Nice. That's a concrete example. So you don't need to have the input being in the domain of the outer function. It needs to be in the inner function for sure, but there's no need for it to make sense when you feed it into f itself, because you're feeding in g of x into f, not x.